We'll continue our discussion on three-phase system. In the last session, we have defined many terms, starting with White's ratio. We have defined it as a ratio of volume of whites to volume of solids. In three-phase system, what volume of whites means is it is volume of air and volume of water. This is volume of whites, and what you have is other part is volume of solids. Now together it makes total volume. So this part I had written volume of solids. Now the ratio of volume of voids to volume of solids, we have defined it as voids ratio. Porosity is volume of voids to the total volume. Degree of saturation, as defined earlier, here it is volume of water to volume of voids. So volume of water is this much. Volume of voids, you got much more, because air of voids of air is also there in that. So volume of water to volume of voids indicate percentage of voids which are covered with water. That is known as degree of saturation. Now water content or moisture content is defined as a weight of water to weight of solids. These four are very fundamental relations on which the whole thing starts. So here there is a volume ratio, here also there is a volume ratio, here also there is a volume ratio, but here water content, which is confusingly denoted by W, it is a percentage. This ratio is expressed in percentage. Of course, for a matter of fact, all these are expressed in percentage. You have to remember, water content is also, or moisture content is also expressed in terms of percentage. So to say, ratio of weight of water to weight of solids expressed in percentage is known as water content or moisture content. We'll go to the next slide. So here I have listed earlier relations also. Now we'll define more terms as far as unit weights are concerned. Unit weight is nothing but specific weight or weight per unit volume. Right. So the first one, bulk unit weight, or it is also referred to as mass unit weight. So these words we should remember. Bulk or mass, when we say, it consists of air, that is gaseous part. It consists of water. It consists of solids too. All of them together we call it as soil mass or bulk. So bulk unit weight is denoted by gamma B. Gamma is the unit weight. Gamma B is the bulk unit weight, which will be a ratio of total weight to total volume. Very simple. Now, what would be the units of measurement? The weight is measured in newtons or kilonewtons. Volume is measured in centimeter cube or meter cube. Now, if you take 1 meter cube of soil, whatever weight that comes, that will be called as bulk unit weight. Bulk means air, water and soil solids all together. It is bulk. Here it is very clearly written. Generally, gamma B, that is bulk unit weight, will be of the order of 12 to 24 kilonewton per meter cube. Generally 16 to 18 kilonewton per meter cube would be the bulk unit weight if it is very compact and water content is reasonably less. Okay, what is meant by dry unit weight? There is a notation, gamma with a suffix D. It is dry unit weight. Now it is a ratio of only weight of solids. Look at this, WS, weight of solids, then divided by total volume. Now, when you take weight of solids only, it may be having water also, it will be having air also. But when we define dry unit weight, it should have only uh, solids weight on the top, and then denominator should have the total volume. Then it is known as dry unit weight. Even for wet soil also you can define this, because in wet soil also what you have to put in the numerator is weight of solids only divided by total volume. This ratio is gamma D, dry. So dry unit weight, here the soil is not dry. We are imaginarily making the soil dry, means neglecting the weight of water. We take only weight of solids in the numerator divided by the total volume. Then it becomes dry unit weight. Here there is gamma S, that is unit weight of solids only. Unit weight of solids only. Here in the numerator as usual weight of solids, but divided by volume of solids. So when you have three phase, then you will realize volume of solids only means it is very small part, because including volume of solids, volume of voids, it becomes total volume, and that is there here in the denominator of gamma dry. But gamma saturated, though the numerator is remaining the same, that is Ws and Ws, here the value of V is more than value of Vs. Because of that, value of gamma D will be much less compared to gamma S, or unit weight of solids will be quite high because the volume is less, weight is remaining the same. Okay, then gamma saturated. What is this? This is weight of soil along with the water, and all the voids are fully filled up with the water. So total weight with all the voids filled up with water, then it is saturated unit weight. That is, that total weight is in the top divided by total volume is in the denominator. This ratio is known as gamma saturated, or saturated unit weight. Here there are more terms refined. Now there is gamma submerged. Now what is submerged unit weight? Equation wise it is gamma saturated minus gamma W. But actually speaking, how it comes is gamma saturated is nothing but weight of 1 meter cube of wet soil, or fully wet soil, or no voids, right? If you immerse this 1 meter cube of wet soil, total wet soil, into the water, obviously there will be a buoyant force of the magnitude equal to the weight of displaced liquid. How much is the weight of liquid displaced? It will be 1 meter cube. So what would be the weight of 1 meter cube of water? That will be gamma W. So much will be in a reverse, or buoyant force. Because of that, submerged unit weight will be a difference of saturated unit weight and unit weight of water. Okay. Then sixth term, relative density. This is relative density, or dr or id is also known as density index. In fluid mechanics, sometimes relative density means specific gravity, so there shouldn't be any confusion. Here it is not specific gravity. We have already seen that specific gravity is denoted by the letter S. The specific gravity is denoted by the letter S. We'll discuss this, what is GS and GM means. So in soil mechanics, the relative density means it is density index. It indicates denseness of the soil. That is why it is called density index. Now how it is defined? ID, density index, is defined as a ratio of Emax minus E natural divided by Emax minus E minimum. Now when you take some soil, obviously it will be having some part of the soil will be having particles, and then some will be having water, etc. Like that, there will be filling of soil particles in a container. But naturally, when it exists, obviously it will be having some voids in it. So that natural voids ratio is known as E natural. Okay, now you loosen the soil completely, refill it without much of the effort being put onto the soil particles, then it will be quite loosely filled in a container. Then you try to calculate what is the voids ratio. So voids will be maximum, because of that what you get is E maximum. Now try to put some effort, that is you use the rammer, compact it as tightly as possible, and then you try to find out voids ratio. In such case, obviously all the voids are completely filled up with uh, soil particles, very tightly filled soil particles. Voids will be less. So in such case also you try to calculate voids and voids ratio, then it will be E minimum. Okay, now the ratio of Emax minus E natural divided by Emax minus E minimum, this ratio is known as density index. Here we'll analyze it this way. Suppose in natural condition itself, suppose the soil in natural condition itself is quite loose. In that case, what happens is whatever Emax we have found by filling the soil quite loosely, it is almost equal to the similar condition. Because of that, if Emax is equal to E natural, this value becomes 0. So density index or denseness index becomes 0, indicating that the soil is existing in quite loose condition. Another extreme, if the soil is having, let us say, very tightly filled condition, because of that it is E minimum, that is natural voids ratio itself is quite less and it is almost equal to E minimum. Now the ratio becomes E max minus E minimum divided by E max minus E minimum, that is to say it is equal to 1. So when, if it is 1, it is quite tight, very dense, and then if it is 0, it is quite loose. So density index, the value varies from 0 to 1. Obviously it has to be less than 1, it has to be slightly greater than 0. So nearer to 0 it indicates loosely filled soil, nearer to 1 it indicates quite tightly filled or quite dense soil. So that is what is the meaning of relative density. Next, one more information that you should carry along is unit weight of water. This is equal to 9.81 kilonewton per meter cube, or 9810 Newton per meter cube, because it is a weight per unit volume. Per unit volume is 1 meter cube. Then rho with a suffix w, that is density of water. Density of water is 1000 kg per meter cube. If you want in CCS system, it will be 1 gram, it will be equal to 1 gram per cc. Means if you take 1 cc of water, how much will be its mass? Its mass will be 1 gram. So density of water is 1 gram per cc. Then here I have some more information. GS, that is specific gravity of soil solids, is specific gravity we have already defined. It is unit weight to unit weight of water. Unit weight of solids gamma s divided by gamma w. GM, specific gravity of soil mass, is a bulk unit weight, weight of the material as existing, right, with air voids, water voids and solids together. That whole thing is gamma b per meter cube divided by weight of water per meter cube. So if you have the picture of three-phase system in front of you where you have solids, and then you've got air, and then water over here, then there is solids. Now in case of denominator, if you look at weight per meter cube of water, it is fixed. But in case of GS, specific gravity of solids, here this is specific gravity of solids in the sense it is concerned with only solids and solids volume, whereas bulk means it will be consisting of all this. So hence it becomes this value is lighter or lesser than this value. Always GS is greater than GM. And lastly, from this slide, we can revise once again density index, which is indicator of denseness. ID equal to 0 indicates the soil is in loosest state. ID equal to 1 indicates the soil is in densest state. Okay, we'll go to the next slide. So here I have a three-phase system already drawn for you, consisting of air, water and solids. Already this VA, VW, VS is written, volumes of air, water and solids. Together air and water, it is volume of voids indicated by E, volume of solids VS, and total volume is sum of all these two. Okay, weight wise, weight of air, which is negligibly small, kept at 0. Weight of water WW, weight of solids is WS, total weight is W. Now to develop basic relationships in soil mechanics, important derivation for three-phase system or three-phase diagram, the most important thing is this, that is you have to put this, that is volume of solids as 1, and because of that volume of solids is 1, by the definition of voids ratio. What is definition of voids ratio? Look at this. Definition of voids ratio says that E is equal to VV by VS. What I am making is 1. Vs equal to 1. Vs equal to 1 indicates that volume of voids is equal to E. Volume of voids is equal to E. So this is the major starting point where Vs is assumed to be equal to 1. Because of that, the definition of E itself makes it clear that volume of voids is E. Now you shift to degree of saturation definition, which is VW by VV. VV is E. Because of that, volume of water becomes SR into E. Now water content, which is weight of water to weight of solids, which is weight of water in the sense it is volume of water into unit weight of water, because we have seen earlier whenever you want to calculate weight, it has to be equal to gamma of that multiplied by volume, right? If you remember this, the same thing has been used here. If I want weight, gamma of water, then multiplied by volume of water, that gives you weight of water. But volume of water is already, we have proved here, S into E, that will write gamma W as it is. Now denominator, you have weight of solids only. Weight of solids is volume of solids multiplied by unit weight of solids. So Vs is substituted as 1. Now unit weight of solids can be written as Gs into gamma W by the definition of Gs, specific gravity. Hence, gamma S can be replaced as Gs into gamma W. In the last slide, we have seen that. Here, we have Gs is equal to gamma S by gamma W. So, gamma S can be always substituted as Gs gamma W. So, by substituting and cancelling of gamma Ws, we end up with a very fundamental relationship. S into E equal to W into G. W into G equal to S into E. There are four terms: water content, specific gravity of soil solids, degree of saturation, and White's ratio. So that is equation number one, most important equation or relationship. Next, number two, porosity. Porosity is equal to, it is represented by the letter N, which is volume of voids to the total volume. And N equal to volume of voids. Now, if you look at three-phase diagram, it is E, and total volume is 1 plus E. So, simple relation becomes N equal to E divided by 1 plus E. If you rearrange this, it can be put as E as a function of N, and it will be equal to okay, next one, uh, relation number 3. We'll start with the definition of gamma B. Gamma B is the bulk unit weight, which is W by V, that is total weight divided by total volume. Total weight is having both weight of water and weight of solids, divided by total volume also consists of voids plus solids. Now, WW, weight of water, already we have seen in upper proof that it is volume of water into gamma W. Ws is Vs into G gamma W. And volume of voids, volume of solids, we know that it is E plus 1. Now, simplification gives S into E plus G is equal into gamma W divided by 1 plus E becomes gamma B. So finally the expression is gamma B equal to G plus S into E divided by 1 plus E. Right, very standard relationship, very fundamental relationship. Using this we can derive gamma D, gamma saturated, gamma submerged, etc. But this will be the basic. Now, knowing gamma B equal to G plus SE divided by 1 plus E SE, gamma B equal to G plus SE divided by 1 plus E into gamma W. Now, suppose if we put gamma B as this equation and introduce water content into that, equal to G plus WG is there. From this and this we can take G outside, it becomes 1 plus W, and all other terms remaining the same. Then ultimately it becomes gamma B divided by 1 plus W will be simply G gamma W divided by 1 plus C. And this expression is gamma D, that will be proving here as equation number 5. So gamma D will be equal to gamma B divided by 1 plus W. Now from this relationship, if S is equal to 0, that is no voids are filled with the water, S becomes 0. So it becomes G gamma W divided by 1 plus C, that is dry unit weight. And by chance all the voids are fully filled up with water, then S will be equal to 100%, that is 1. Gamma saturated becomes G plus E divided by 1 plus E into gamma W. That is sixth relationship. Then gamma submerged is equal to gamma saturated minus gamma W, we know. Gamma saturated is already proved, G plus E divided by 1 plus E into gamma W minus gamma W. If we take gamma W outside and try to simplify, gamma submerged becomes G minus 1 divided by 1 plus C into gamma W. That is what is the seventh relationship. So in this slide we have discussed about unit weight of soil in different conditions, and then one fundamental relation, S into E equal to W into G. So here we'll stop.